This video will present solutions to the VCE 2022 Mathematical Methods Written Examination 2, Section A, questions 16 to 20. Question 16. To answer this question, a system of three equations in three unknowns m, n and p will need to be solved. Probably the most efficient way to do this is to use the ClassPad's main app. From the Math 1 keyboard, we need to tap the simultaneous equation icon twice to create the 3x3 template. For the first equation, I'm going to use the fact that the function passes through the point 3, 4. This means that the first equation can be found as the function equal to 4 given that x equals 3. When entering this function, you will need to use the variable keyboard for m, n and p, and from keyboard 3 the vertical line symbol for given that. The second equation can be formed based on the fact that the function is at a turning point when x equals minus 3. That means that the derivative of the function is equal to 0 when x is minus 3. Start this second equation using the derivative template from Math 2. Its arguments are the variable x and the function f of x, which, with a little care, can be selected, dragged and dropped from the first equation. Now set this derivative equal to 0 at x equals minus 3. The given that symbol is needed once again, accessed via Math 3 or swiped from the first equation. The third equation is similar to the second one, as it is also based on a function stationary point, this time at x equals 1. As such, duplicating the second equation and editing the x value is all that is required. Finally, enter m, n and p as the variables to be solved for. This solution is answer B. This method could also be implemented without the assistance of CAS, but such a method has the potential to be time-consuming and prone to error. Question 17. This question is a bit different in as much as it gives information about the average and instantaneous rates of change of a function, and then asks about a range of properties that this function might possess. To get a feel for what's going on, I'm going to draw a sketch based on the information provided. Based on the positive average rate of change from A to B, I know the function g increases over this region. Based on the negative instantaneous rate of change at the midpoint of this interval, I know that the function's gradient is negative at this point. Joining the dots, the function could look something like this. There are many possible shapes that fit this information, but they will all have to feature a turning point in order to fit the facts. As such, the function must be many to 1. Based on this thinking, the answer is A. Question 18. In this question, we are given the parameters n and p for a binomial random variable, and are provided with this conditional probability statement. To find the value of A, I'm going to implement a trial and error approach, which seems like a good option due to the multiple choice structure of the question as well as the integer nature of A. To start with, in ClassPad's main app, I will calculate the probability of x greater than or equal to 16. Do this by accessing the interactive menu and choosing the distribution option. From the discrete section, I will choose binomial CDF. This opens a pop-up that calls for the lower and upper bounds on x, being 16 and 20 respectively, as well as the number of trials, 20, and the probability of success, 0.88. With these values entered, tap OK. Using this calculation, I'm going to form the conditional probability expression, the probability of x greater than or equal to 16, over the probability of x greater than or equal to A. With this structure in place, all I need to do now is change the value of 16 in the denominator to the first A value that I wish to test. The probability when A equals 11 is close to the value provided, but not equal to 4 decimal places. Next, trying A equals 12, we obtain the value we are looking for, and so the answer is B. Question 19. This question asks for the outcome of an optimization process that is hopefully familiar to you, but will require a number of steps to be performed. It might be helpful to draw this sketch of the sheet being folded. From this, we need to come up with an expression for the volume of the open top box in terms of x, based on the product of the box's 3 dimensions. From here, we need to find the derivative of this expression with respect to x, set it equal to 0 and solve. I'm going to do this via the interactive menu, choosing Calculate and Diff for differentiation, then tapping OK. I will now set this answer equal to 0 and solve it via interactive equation solve. As we might expect, given the quadratic nature of the derivative, we are provided with 2 solutions corresponding to answers B and D. So, which is it? Well, thinking about the expression for the volume, it is cubic with a leading coefficient that is positive. Such a cubic with 2 stationary points will look something like this. As such, the volume function will have a local maximum and a local minimum. The maximum will occur before the minimum, and so the lesser of the 2 values will be the one that we want. Observing the positive and negative signs, this means our answer is D. Question 20. This question provides us with a function for the horizontal distance that a ball travels, in terms of the angle with which it is kicked. As sin 2 theta has a period of 180 degrees, a graph of this function will look like this. We are interested in a ball travelling more than 40 meters. The theta values for which this ball travels exactly 40 meters can be found by solving this equation. I'm going to solve this numerically for theta between 0 and 90 degrees. Now we know that the theta values required are between 26.57 degrees and 63.43 degrees, we can use the normal distribution that models theta to find the probability of such values. Calling up from the interactive menu the distribution option, choose continuous and the norm CDF. Enter as the lower and upper the bounds on theta found previously, and enter the sigma and mu values provided. Tapping OK, we see the probability is closest to answer A.